Hi everyone. Thank you for joining. Today, we are going to see how to debug Go from zero to Kubernetes, which is the perfect talk after lunch. Ease your digestion. So, let's start with a little introduction about myself. So, my name is Michele, and I work in Amadeus, which in short is a company that creates software and services for the travel industry. With my team, we develop tools in Go to assist applications that are migrating to the cloud, so middleware tools. I work in Go since version 1.10, which is 2017, more or less. And on my free time, I'm also a co-organizer of the Riviera Dev Conference, which is organized by a no-profit organization every summer in the south of France. So if next year you are in that area and you want to attend our conference, join us either as attendee or as a speaker. We will be happy to see you there. So let's have a look more in details at what we are going to see today. So first of all, we will make a little introduction about what is debugging, what are the tools that we use for debugging, and then we will focus specifically on the debugger tool and on Delve, which is the specific tool to debug a Go application. Once we have done this introduction, we will start to see how to debug a Go application that is running on a local environment, on a Docker container, and a Kubernetes cluster. We will do this step by step. By the way, if you don't know Go, it's not a problem. The concepts that I'm going to share with you today are also applicable to other programs written in other programming languages. They may require some adaptation, but the general concept is what you're going to see today with Go. We may not have time to see a live demo of how to debug a Go application in all these environments, but for this reason, I created a specific repository that I'm going to share with you at the end of the presentation with the slides. In this repository, you will find all the code and the documentation needed to reproduce the same steps that I'm going to show you today to debug a Go application in all those environments. And most importantly, you will also be able to learn some code, and in particular to see how to create cool ASCII art GIFs in Go, like this one, if you can see it. It's cool, I assure you. So let's start. First of all, just to be on the same page, let's see what debugging is. If you look at the definition up in Google, you can see that debugging is the process of identifying and removing errors from computer hardware or software. And how can we do that? We have several tools at our disposal. For example, we have all the tools that we use to create tests, like unit test, integration test, end-to-end test. Those are tools that we use to debug. Then we have data-driven tools, the ones that we use to collect data with like logs, traces, and metrics, and the tools that we use to exploit those data and make something like create graph, send alerts, or take actions. And then we have live debugging with the tool that we are going to focus on today, which is the debugger. Now, again, just to be on the same page, let's see what the definition of the debugger is. We are going to look up in Google again, and we'll see that the debugger is a computer program that helps us in the detection and correction of errors in other software programs. And again, how do we do that? The debugger lets us interact directly with the running application. We can do that by, for example, viewing the code that is under debug. We can manipulate breakpoints so that we know exactly where we stop. We can advance through the code at our pace, so getting inside a function, outside, step one instruction next, and so on. We can check the stack trace, we can check the variables, the parameters, whatever. There are a lot of actions that the debugger can allow us to do. But it's not just about debugging. In fact, if we leverage the fact that we can advance through the code at our pace, we can see exactly where the code goes when we investigate a bug, for example. We can see why it goes on a certain direction with respect to another. We can see what happens if we modify a variable or a parameter, what kind of code is executed at that point. So in addition to being able to find bugs, we can also learn about how our code is working. And it's a very positive effect of the debugger tool to make sure that we understand exactly what our code is working, especially if we are embarking in a new project and we don't know the code yet. Now, a word of caution about the debugger. It's not all positive, unfortunately. The debugger disrupts the application that it's being debugged, in the sense that it stops everything, takes control of it, and gives us the possibility to interact with it, which means that the application traffic is impacted. So if we do this on our local environment or on a development environment in the cloud, it's fine, because we don't expect our customers to come to our laptops or to our development environments in the cloud to shoot traffic and execute their business logic there. But as soon as we need to debug in a production environment, or at least outside the development environment where the customer is executing his logic, then we have to be extra careful. For example, we can think about having services in Kubernetes to make sure that we separate the traffic that goes to the debugger with the traffic that goes for the pods that are not under debug. There is not one single solution for this. You have to be careful and make some experience on it to make sure to make the right decision. Now, we have done this introduction. We can start to see how to debug Go in local. To do that, we will need our tool, Delve, which is the specific debugger for Go application. It's an open source tool that you can download and use, and it can be used either as a command line interface, as we are going to see today, and as a graphic user interface integrated in Visual Studio Code, thanks to the Go extension. So, to start Delve in local, it's as easy as executing the DLV command, followed by one of the specific action that you see there. For example, in the animation that I put in the slide, I'm running delve debug main.go, which means that I'm telling Delve to compile the code and start the debugger on it. Then I start doing some commands in Delve, but we'll see this later. First, we can see that there are other actions like delve exec, which debugs a precompiled Go executable. So you can build your executable and then start delve exec on it. If the executable is started, so you have a running process with the Go application, you can use delve attach instead. And last but not least, you can also debug unit tests with DLV tests. Now, as I said, once you start DLV, you are opened into an environment is started, and you can type any kind of delve commands. What you see in the animation are commands that enables us to list the code, to view the code, to continue to step one step further or inside the function, and to view some parameters and some arguments. But the most important command you need to take with you, at least for the first time, is the help command, because it is very useful to list and explain exactly all the commands that you have available in Delve. Once you see all the documentation, it will be very easy to start the debugging. So you see, starting the debugger in local, it's as easy as running a command in the command line. But how do we do that in Docker or Kubernetes? How can we start Delve in a container or in a cluster? What kind of configuration do we need to make sure that it works also outside our local environment? So no panic for that. We're going to see all of this step by step, and starting with Docker. So let's see how to debug a Go application running in Docker. First of all, we'll need two containers, one for the application that is responsible to run the application, and one for the debugger, which is responsible to run the debugger and debug the application. Fairly easy so far. Now, since we need two containers, we will need two Docker files. Again, one for the application, which contains only the information needed to run the application. So like if there was no debugging involved. Then we will need the Docker file for the debugger image. And this one is more specific. It depends. In the case of Go, for example, I'm taking a shell and a Go toolchain from the first line, from the base image. Then I'm taking the DLV tool with Go install in the second line. And then I'm copying the source code so that I can use Delve to watch the source code when I need it. But this is where the speech becomes generic. If you have to debug an application that is not written in Go, the important thing is that you take the tool that you need to debug your own application. So retain this when you leave the talk. If you need to debug another application that is not written in Go, it's still possible, and the same concept applies with some adaptation. Now, this Docker file is very minimal and simple. It just lists all the tools that you need. Now that we have these Docker files, we can build them, we can publish them, and we can run them. So let's see how we can run those things. First of all, we'll run the application. And to run the application, you run it as you would do normally, without any reference about the debugger container. The only suggestion that I give to you is to use a name with the name flag, so that you can reference the container of the application in an easier way. Then, once the application is running, you can start run also the debugger container. And to run the debugger container, you'll need 2 additional flags with your Docker run command. The first one is the PID, and the second one is the capadd. And we are going to see this more in details, and also why we didn't see those flags in the local environment. First, we will start the PID. We will see in these slides that I'm going to switch between Docker manual and Linux manual, so pay attention to this. First, we will start with the Docker manual for the PID flag. The Docker manual for the PID flag at the beginning says something that we know when we start learning about Docker, which is that all containers run in isolation, which means that if we take our application and our debugger, the 2 containers that are running them are running in isolation. They don't know about each other. The purpose of this flag is to say, when I run this Docker run command and run the container for the debugger, I want to have access to the processes that are run inside the container that I'm specifying in the value of the PID flag, which is the container of the application. So thanks to this flag, the debugger will be able to list and see what are the processes running in the application container. And if you take the time then to see the last paragraph, you will see that this option is actually made on purpose, so that one usage of it is to be able to create debugger containers. Now, we'll go to the capadd flag. If we go and see the Docker manual again, we'll see that it's related to runtime privileges and Linux capabilities. And in particular, the capadd flag is related to adding Linux capabilities. We'll go on that slowly. First, if we see the paragraph below, we will see that by default, Docker containers are run without privileges. So there are certain permissions that each container lacks. And one of these will be, of course, the possibility to debug another application in another container. And that's why the flag capadd will help us, because it says it adds Linux capability. Now, it speaks about capability, so we go to the Linux manual and we see what a capability is. Capability is a privilege that we can assign to a process in Unix. Again, in the description of the Linux manual, it says a similar thing that is said in the Docker manual. The Docker manual talks about privileges in containers. The Linux manual talks about privileges in processes. And it's the same situation. So if by default, the processes in Linux start as unprivileged, so they don't have specific permission, but you can assign them permissions thanks to these capabilities. And now that we've seen this, we can see what is the meaning of this value sysptrace. This is a table coming from the Docker manual, and it says that sysptrace gives the possibility to trace arbitrary processes using the ptrace something, and this something is a system call. Back to the Linux manual. So the ptrace system call, again, is something that helps us because it gives the permission to one process that I will call now the debugger to inspect and interact with another process that I will call the application so that it can debug and inspect it. And this is also stated in the description that its primary use is for debugging. Now, we have seen the description about these 2 flags. Now, why didn't we see them in local? Long story short, in Docker, we have an application and a debugger container that are separate and run in isolation. And also they are started by their own specific users. So we will need the possibility to share the processes of the application so that the debugger can see them. And then we will need the permission to give to the debugger to be able to debug the application. In local, this is not happening because, first of all, the processes are in the same namespace, which means that when we run our terminal and we run PS, we see both the application and the debugger running in the same space. So we are able to see them already. We don't need an extra permission to have the visibility on those. And also, we are the same user that are starting them. So we have the same level of privilege when we start the application and the debugger. If we had, for example, started the application with sudo, which is a higher level of privilege, we would not be able to debug the application without having the same level of permission. That's why we didn't mention this before. Now, we have seen a lot in details about those flags. Let's see what happens when we run the container of the debugger. So since in the Docker file we included a shell is opened to us. So we can use it. We can try to see, we can actually find the process that is running the Go application because we gave the permission thanks to the PID flag. And we can run delve attach on the PID of that specific process because, again, we gave the permission thanks to the capadd flag. Now, from this point on, we can start interacting with our Go application and debug it as we did in local. So that's it. You are ready to debug a Go application deployed in Docker. And by now, we've done most of the work. And we'll see why by moving to a Kubernetes cluster. So the idea when moving to a Kubernetes cluster is to reuse the same approach. We want to have the two containers, one for the application and one for the debugger. We want to provide the debugging capability, so being able to debug the application. And we need also to be able to share the process namespace so that the debugger can see the application. So let's see how to do it. One solution is to create a deployment resource. It will contain the two containers, the application and the debugger, and two additional settings. The first one being the share process namespace set to true, which is the one responsible to make sure that we can see the processes in both containers. And the second one is the security context capabilities add CSP trace, which is going to give the permission to the debugger to be able to debug the application. Now, you can try this, it will work, but let's consider it for a second. Do we really need to have a pod always running with a debugger inside? Ask this because there are two main issues with it. First of all, it's not ideal in terms of security because imagine that an attacker by default is able to access only to the application. Now, with the debugger deployed inside the pod, he has two possibilities to access it, the application and the debugger. And more importantly, the debugger has higher privileges. It can access the application, it can disrupt it. So it's really not ideal on it. Second, it's a problem of resources because again, we are deploying a pod with two containers instead of one. So we may be asking more resources than necessary. And if you have a look at the sizes that I'm showing here in the image, the size of the debugger is almost 500 megabytes, which compared to the one of the application, which is 10 megabytes at most, it's way too much to have it all the time deployed. I have to say that the implementation of this Docker file is the one that we saw before, and it's a very naive one. It can be improved a lot, but still you have to consider that this is some resources that we are paying for. So it's better to think of an alternative if possible. So the approach of two containers is not bad, but we need to make sure that, for example, we can add the container for the debugger only when we need it. Is it possible? Actually, no. We need to change the deployment configuration that we have seen earlier and redeploy the deployment and the pod all the time. So we have to add it, remove it, add it, remove it on the configuration. It's not ideal. But is there any other resources that can do that, that can be attached to the pod on the fly? And the answer is yes, there is one. And it's the ephemeral containers. The ephemeral container is similar to a container. It has the same specification in the documentation, but there are some restrictions on the fields that you can use. And it's meant to be added to a pod temporarily, but its purpose is only to be used as a debugging tool or a troubleshooting tool. It's not meant to be used as a regular container running an application. So the ephemeral containers is a key resource that Kubernetes provide in order to be able to debug any application actually deployed in a cluster. So let's see how to create it and how to use it, at least in an introductory way. So first of all, the changes that you have seen in the blueprint earlier, they are not needed anymore. The configuration that you need to do for your application should only contain information about how to deploy and execute your application, like if the debugger was not existing at all. Then, to create an ephemeral container, you started by running kubectl debug. And to start the ephemeral container, you'll need to provide some information. First of all, which is the pod that you want to debug, which is the application pod. And in addition to the pod, you also need the target container with the target flag, because this flag in particular provides the share process namespace feature. So thanks to this flag, we'll be able to see the processes of the application. Then we will need to provide information about which is the Docker image that we are going to use to debug our application, so the Docker file that we've seen earlier. And we need to provide the debugging profile, which is the one that gives the possibility to the debugger to debug the application. So the CSP trace capability that we have seen in Docker. And this we do by adding a flag profile with value general. Now, once we have done this, kubectl debug starts the container, the ephemeral container for us. And since it's the same container, it will open a shell for us. And we are back to Docker, where we can look for the process running the Go application, because thanks to the target flag that we added, we can see the processes of the application. We can run dev attach on the process ID of the application, because we have given the profile general in the kubectl debug command. And that's it. From this point on, again, we can start interacting with our Go application and debug it like we did in Docker and in Local. So congratulations, everyone. Now you know how to debug your Go application in Kubernetes. We did it. Thank you. So we'll go slowly on the conclusion. Just before we leave and before you ask me a question, let's see what we have seen today. So first of all, we have seen how to start a debugging session in all those environments. So we started from a local environment, we continued on Docker, and we ended on a Kubernetes cluster. Step by step, we have seen the differences between each environment and why we needed something or not. But the most important part is that as soon as you are able to debug your application in Docker, you're also able to do it on Kubernetes by adapting the options that are used in both environments. Then it's not just about debugging Go application at the end, because as I said, the important thing is that you bring the tools that you need to debug your own application in the debugger container. So be it C++, be it Java, be it whatever you want. You can do that in the same steps that we did before, with some adaptation for sure, and making sure that you have the tools that you need. Then remember that the debugger is not a replacement for the debugging tools like test, like graphs, like matrix, like logs that we have seen earlier. It's an additional tool. It helps us debugging the code, so finding errors and remove them. And also it helps us in learning the code. And this is actually the most powerful action that the debugger lets us do, in my opinion, because you can take your own time to see how the code executes at your own pace, really. step by step, you see which instructions are run. And if you manipulate the code in some way or another, you can see what are the differences. Then, last but not least, use the debugger with care when you are outside the development environment, because remember that you are disrupting the flow of the application. And if the customer is passing through the same environment where you are debugging, it may be very tricky to handle the situation. Now, if you want to know more about what I've said today, I'm going to leave you some references. Again, I will share the slides with you. And you will find me in Twitter, in LinkedIn, and in GitHub, so feel free to follow me. And if you have any more questions, just come and look me up. I will be around in the 2 days. I hope you will be able to debug your application whenever you want, wherever you want. And thank you very much for having me.
Thank you very much. Great talk. We'll have quite a few questions,
yes.
And we have time, which is cool. Just looking and get this one. All right. So, do we see the questions? Yeah. So the first one is the debug container required, and could you also run the debugger on the host?
So yes, the debugger container is not strictly required. You can actually merge. Well, you can bring the tools to debug with the application. It's your choice to do it or not. I prefer to keep the two separate because you need to separate the responsibility. So the application is running the application and the debugger is running the debugger. And then you need to find a way to connect them. And that's what we have seen today. So yes, you can also run the debugger on the host. Absolutely.
Another question that we have, how would you apply this on a production environment? Would it not freeze up the application?
The answer is yes, it would freeze the application. As I said, the application is disrupted. So you need to take some preventive actions. You need to have some procedures to do this. I can give some suggestions. For example, you can use services to make sure that there are some services that redirect the traffic for yourself to the debugger container, so that you are sure that only you are targeting this specific service, and leave the service for the application to target only the other pods. And you can use this with services, with the selectors, applying the proper labels. Or other things, you can set up a freeze period where you can say that the application is disrupted and there will be an outage. There are several strategies that you can think of, and it depends really on the kind of impact that you are going to have on the application. So whatever suggestion you will take or new idea that you will have, think carefully about how to apply it, and remember that behind you will be impacting the traffic. So this is the most important part. Then how to do it is up to you, which is the best strategy to choose. Can we debug broken containers?
Can we debug? Sorry, broken containers.
I haven't tried that. I have only tried with running containers. So I will take the question offline, and if you ask me again, look me up, and we will chat about this again. I will test this.
I don't have the exact same anyway. How practicable is to use the debugger container without a copy of the source code?
Not much. You will see machine instructions. If you like machine instructions, it's fine. If you like source code, take your source code. It's better. It's not mandatory by any means.
Does this mean that the binary should not be stripped?
Okay. The important thing about the binary is that that it has the references of the source code inside itself. In Go, I know that it's the case, so the debugger will find the path of the source thanks to the binary. For the other programming languages, I don't know.
I think you've already answered this one during the talk. Do you know if this is possible with any other languages?
Yes. In fact, what I shared with you today are some principles and an introduction on the way to debug an application written in Go. with all the steps that we have seen today. But again, the important part for me is what you take with you in the debugger container. Then also maybe there will be some adaptation needed for other programming languages, but for this I don't know in specific.
And one last question, is there a difference when using telepresence to stream the traffic to your local machine and debugging code in VS Code?
No, it's equivalent. You can do debugging in command line or using telepresence with VS Code. There is absolutely no difference. It's in this context, it's what suits you the best.
Got it. One last question in the audience, perhaps? None. Thank you so much for your talk. A round of applause, please.
Thank you.